Hello, good morning. My name is Ashutosh Garg and I work for Furnace Improvements. I welcome you all to our new format of 15 minutes webinar. Previously, we had been doing an hour-long webinars, and then we realized that attendees don't have that much amount of time, so we have shortened this webinar duration, and we hope you will like it. So today, we'll be talking about how we extended the run length of a crude heater from 1 year to more than 5 years. Crude heaters, as you all know, are one of the most important heater in the refinery. It is the first heater through which the crude flows, and it is often the largest heater. Now, crude heaters suffer from coking, flame management, and short run lengths. Even though refiners want the crude heater to run for 5, 6, 7 years. Most of the time they have to be shut down after 2 years for cleaning. So this refinery was having a lot of issues. That they had two tube ruptures in a span of about 8 months, and that's when they called us for help. So we want to show you what we did and how we increase the run length for more than 5 years. I hope all of you know us. Our company, Furnace Improvements, completed 29 years this year in March. We have two offices. Our main office is in Noida in India, Uttar Pradesh. It's been there for last 20 years. That's our main engineering office. We do process design, mechanical design, structural design, CFD modeling, all those things over there. And then we have our Sugarland office in US, Texas, where we are doing the sales and project management. We have a very unique approach for the last more than 25 years. We work directly with owners and refiners like you. We have tried to establish a doctor-patient relationship and cut the middleman out. Our approach has been contrarian, and we try to provide unique value added solutions. We have always challenged the conventional wisdom, and we take pride in doing high quality technical work. We are able to work round the clock because of time difference, and our objective is do it once, do it right. These are our engineering capabilities. We are full service engineering vendor. We take We have lots of process engineers, 6 process engineers to be exact. And then we have mechanical disciplines, structural disciplines, 3D model, etc. And our client list is worldwide client list. Most of the business we get is through referrals or through word of mouth. Phillips 66 is our largest client. We have been working with them for more than 27 years now. So, and we have worked with other refineries also. So today's case of crude heater we are talking about is from a Texas refinery. And this crude heater was a very unique heater. We call it a vertical cylindrical two cell with a common convection section. And as we will show it to you, it was not exactly cylindrical, it was like octagonal, And it had a common air heating system with a vacuum heater. The crude heater was built in 1975. It was designed for 125,000 barrels per day. In 1997, they revamped it to 165,000 barrels per day. And The heat duty was kept the same, approximately 261 million BTUs. That's just a flow diagram we are showing you over here. The heater had lots of issues. In fact, I think in the after 10 years of operation, they started having frequent decoking issues. And every time they had to decoke, they had to shut down the heater for 3 days and spend $1 million. So from the operating history, the client told us that the heater coked up in 2008. And then in September 2010, they had the first tube failure. The second tube failure occurred after 6 months in February 2011. And then they called furnace improvements in March, and they said, we need help to eliminate these tube ruptures. And that's when we got into action. To give you an idea about the heater had two, as I said, two octagonal cells. Each cell had 12 burners. The burners were originally designed for about 12.5 million BTUs. But in 1997, they increased the firing rate by 25%, and the heat release of each burner went up to 18 million BTUs. These were 4-stroke burners running at about 10% excess air. The crude heater had other issues, like they had water in the feed. So two-phase flow was occurring in the inlet of the crude heater, and they suspected non-uniform uniform feed distribution in the passes. Firing rate often exceeded 400 million BTUs. The convection section temperature was 900 degrees, and the heater always ran, or most of the time ran, on positive pressure at arch. We solved that problem, and we will have another webinar to show you how we fix the positive pressure problem with the existing ID fan. The airflow distribution to both the cells was not even uniform. East cell would get lower combustion air, and they would have more problems in the east cell. So heater had lots and lots of issues. We started analyzing it, modeling it. We found that the flux is very, very high, 15,000 BTUs. Bridge wall temperature was almost touching 1800 degrees. There was a lot of overheating and flame impingement on radiant tubes. Burner flames were very long. At about 20 feet elevation, that's where they had the tube ruptures. So once we analyzed the heater, the client gave us objective. They said, hey, we want to reduce the tube metal temperatures, eliminate tube failures, re-rate the heater to process 165,000 barrels per day charge, ensure uniform flow into all the 12 passes, use the existing burners, and fix ID fan. So these were some of the objectives they gave us when we started the study. And we analyzed it, and after I think about 3 months, we came with a solution saying that we can help you by installing burners at an angle to eliminate flame impingement using our patented inclined firing technology. We also made several other recommendations, including upgrading the convection section to reduce the radiant heat flux and reduce the load on the air preheater. But the client did not implement any of those recommendations due to cost consideration. Replacing a convection section is a very, very expensive proposition. The client said, we want you to reuse existing burners due to a permit issue, and the burners cannot be modified. So we carried out CFD modeling for almost 6 months with existing burners to arrive at the optimum burner configuration. And it took a long time. They even had an engineering company working with them, so we had to satisfy the engineering company as well. This is some of the CFD results. We did extensive CFD modeling, as you can see, for 6 months. So these are some of the CFD results. These are what I'm showing you are flue gas velocity vectors. And on the left side is the existing case, right side is the proposed case with the inclined burners. And you can see in the existing case, the flue gas was touching the tubes at about 20-foot elevation. And what was leading to that bending of the flames was the presence of a flue gas recirculation loop currents in the center, like a vortex, a vortex was forming inside the firebox, and that was pushing the flames to the tubes. So this is the existing. When we put them at an angle, we realize that the vortex has disappeared, and we have the flames going straight, up and illuminating the touching. These are the flue gas temperature contours, and you can see this is the existing contours, and you can see the flue gas, hot flue gas, almost like 2000 degrees, 2200 degrees, touching the tubes, over here. And if you look at the proposed, the hot flue gases are in the center, and in the near the tube, we have cold flue gases. So we could see a big difference in terms of flue gas temperature contours. And then we did the cut the radiant section and saw the flue gas temperature contours at 10 feet elevation. So the benefit of CFD modeling is you can do any cross section. So you can see the flue gases, hot flue gases are concentrated in the center, and outside is all cold, whereas here they are all over near the tubes, This is at 15 feet elevation. You can see a stark difference between the existing and the proposed case. This is a CO. So we assume that anything more than 2000 ppm of CO is flame actually. And you can see the flames all over in the existing case. And this is the flames in the proposed case. This is a 10 feet elevation. This is a 20 feet elevation actually, which is very, very important. You can see the flames were a little longer, but they were still in the center of, So the important point is keeping the flames away from the tubes. And we did the modeling of the tubes, and you can see it was almost like 1100 degrees F in the bottom 1/3 of the tubes, whereas once we did an inclined firing, all the hotspot disappeared, and the tube metal temperature, the heat shifted in the upper half of the firebox. So the proposed modifications are only in yellow. So we only change the part of the bottom floor, in both the heaters and the new plenum. Because we were inclining the burners, we needed to put the burners at an angle. So we needed a new plenum. So that's all modification which we did. Everything else was existing. Very, very effective, cost-effective modification we did. And the results were startling actually. The client started the crude heater in December of 2012. And tube metal temperature, we had given them a guarantee of 200 degrees F. We had given them a guarantee of 100 degrees F, and the actual temperature went down by 200 degrees. And client achieved a run length of almost 6 years. They did not have to shut down the heater, but they shut down the heater to take care of the equipment, other equipment. So inclined firing technology in the nutshell is takes care of the biggest problem in heaters, especially the high tube metal temperatures or coking or flame impingement, because it moves the flames away from the tubes. Does not make any change in the heat transfer, and we have seen the tube metal temperatures are lower by almost like 100 degrees to 200 degrees. Very simple. We can do it in the new heaters also. These are some of the benefits: longer tube life, reduced coking rate, elimination of hot spots, better flue gas recirculation, and uniform tube metal temperature. This is from another heater we did. We can show it to you. And every 10 feet of elevation buys us another 1 foot of extra clearance between the burner flame and the tube. So at 20 feet, we get another 2 feet. At 30 feet, we get another 3 feet. So it's almost like uh, a big relief. The flames are away from the tubes, and yet still they are transferring the heat. We have done it in about 15 heaters, and all the heaters have been very, very successful. If you are having any issues in any of your crude heaters or even vacuum heaters, any refinery heaters, you are experiencing high tube metal temperatures, we can help you by installing our inclined firing technology. Thank you very much. I hope you liked my short presentation to improve the run length. We are there to help you out. Give us a call or send us an email. Thank you all. Bye.